Good morning, everyone. Welcome all. Indeed, it is pleasure. It's an overwhelming response from industry professionals and women who wanted to come back, or even generally people are excited to learn because of the topic AI for all. Happy to receive you today and looking forward to have a wonderful session. Before just starting a little intro about us and the speaker. So we specialize on bringing the future skills to the professionals as well as for the women who has taken a break. And we are just currently bringing the development stream for people who wanted to know about the recent development trends that includes Python and even the other languages, data science, etc. And also, we are also partner of a UiPath, wherein we are just bringing the automation professionals. So any help on these trends, we are more than happy to assist you all the time. Today, we have Rajiv, who is just a partner, a senior partner, as well as the MD for BCG. And at his capacity, he handles the AI for all most of his clients, as well as he collaborates with NASCAM as well as part of BCG initiative to bring the AI for all. So along with Rajiv, today we do have Rohan, who is just a 12th standard kid who is going to tell you and share you AI can be practiced and then learned anywhere and anytime. So age is not a barrier. Thank you for both of you to joining with us and happy to just be with you for hosting this session. Thank you. And Rajiv, over to you.
You should have no problems in doing so. I wanted to start out with a video. Manjula, if it is all right with you, if you could play that video, please, that would be great. Manjula, you're on mute. Manjula, you're on mute. You'll have to unmute yourself.
Yes, I have just done that. Thank you.
You have to press the play button.
Yeah. Sorry.
Press the slideshow.
No. It's just construction. That's all. I'm driving. You okay? Yeah. You? I'm good. No, not you. Listen, I'm gonna have to call my agent. I'm gonna get back to you.
Mr. Burton, this is Insurcorp. We've received sensor data that indicates you were in an accident. Are you injured in any way?
I'm not injured, no.
Is anyone else injured?
I don't believe so.
Okay, where's my agent's number?
We have pinpointed your location and we are showing your car is not drivable. So we are dispatching an Uber car to take you to your destination.
That would be great.
I'm pressing 1. English. E-N-G-L-I. English.
May we give your coordinates to our appraiser drone to perform the appraisal?
Absolutely.
We have received the photos, assessed the damage, authorized the repair, selected a qualified repair facility, and have dispatched a tow truck to take your vehicle to that facility.
Perfect.
Yes, hi, this is... Yes, I'll hold.
We have looked up the other vehicle's insurance, transmitted the appropriate data to create the claim, and filed the California SR1 accident report. Can you confirm the information is correct on your phone, then hit the accept button?
I'll check it right now. Okay, all done.
Thank you. Your Uber car is arriving now.
I see it coming.
Accident, not payment. Accident.
Your tow truck should be there now. Don't forget to leave your keys in the vehicle. Thank you for using Insurcorp, powered by Pivotal Labs.
Thank you, Manjula. If you could stop the video now. So this was an interesting video we thought we'll share. It's about two cars that crash and how an individual's life is made much simple by the use of technologies and how somebody else is still trying to use the call center. Ron, you want to add on what kind of technologies you see out here?
Yeah, so the video that shows 5 technologies that are already in use: sensors, voice activated auto calling, drones, Uber, and mobility. And then it shows how AI can be used to integrate all 5 of these technologies together to make somebody's life simpler, to make processes quicker.
Manjula, if you could just pause sharing and I'll share my screen if that's okay. Yeah. I hope my screen is visible. So look, with the use of that example, what we wanted to talk about, one is, why is AI so important? It's very interesting. The first known use of the word artificial intelligence was in the year 1929, almost 90 years back. It was actually used in a German movie. So one could argue that while the word and the phrase has been in use for so many decades, why are we talking about it now? The reason is that over the last 10 years or so, the volume of data that has proliferated, the kind of cost of storage and computing power that has come down and therefore made much more powerful technology available, and the use of therefore analytics from scientific labs to actually many of us starting to become data scientists. These three combinations have made artificial intelligence very possible, and it has actually become an integral part of our day-to-day lives. So I'm going to take two types of examples. One, examples that impact us on this call, and two, examples that impact the organizations that we might be working for in our previous lives or currently. I'll just take one good story. So I was a guest speaker at a conference in Europe, and there were 6 of us who were supposed to be on a panel, and we were asked to wait outside the conference room in some other little waiting area. Then when the conference was about to start, we were taken into the room. The room had round tables, and each round table already had one individual sitting there. So I went and sat at the round table I was supposed to sit, and actually I realized that the individual sitting next to me was not a human being, it was actually a robot. Very interesting, the robot turned around to me and said, "Hello." And I said, "Hello, my name is Rajiv." And the robot said, "Hello, my name is Jay." I thought, okay, good. I have seen a few gimmicks of this nature, nothing great about it. And maybe the robot has just been trained to say that. After a couple of minutes, I got up and I said, "Jane, I'm going to go and get a glass of water. Would you like a glass of water?" Just to test what the robot says. And the robot answered, "No, Rajiv, fluids don't go well with my body." That wasn't the end of it. The 6 of us were called up on stage to speak on the panel. And interestingly, the moderator then asked a 7th individual to come on stage, and that 7th individual happened to be a robot. There are various questions posed to us, and the robot's ability to process information available to it through the vast, array of information through various databases and all, process it while a question is being asked and give that kind of feedback was immense. Now, the example I'm taking effectively shows how data is getting processed and converted into intelligence through an algorithm that then comes and solves some problem of ours. I also want Rohan to take an example or two of what even a 17-year-old is able to see as a use case in his day-to-day life.
So I'll just take the example of an integrated smart home first. In an integrated smart home, when you leave your house in the morning to go to work, a smart home will automatically switch off the lights, switch off the AC when you leave. And about 20 minutes before you arrive, it'll be able to tell when you're arriving simply based off GPS and see that you're moving. It'll switch on the AC before you arrive so that when you enter the house, your house is cool. When you enter your house, it'll use sensors to track your movement and see that you've entered and it'll switch on the lights for you. Another example is that of an autonomous car. So both Tesla and Volvo have been developing autonomous cars. And in autonomous cars, they use sensors to detect whether there's a car in front, a car behind you, and maintain a safe distance from those two cars. they can also detect the white lines on the road and make sure that this remain within the white lines. So using sensors out there, using sensors that able to drive by themselves.
Perfect. So I think what we are seeing is there are three things, there are three variables that come to fruition for AI to work. It should be able to sense, and whether that is sensors, whether that is speech, whether that is visual images, it should be able to sense. It should be able to think, and the thinking happens through some alerts, through some monitoring, and through some algorithms. And then it should be able to act. It should be able to answer a question. It should be able to turn the wheel of a car. It should be able to make a robot stand up and shake hands. As soon as you can get sensing, thinking, and acting to happen, that's when AI starts, becoming real. We took some examples that sound cool, about smart lighting, smart cars, robots. In our day-to-day lives, AI is not only cool, it is actually being used to drive revenues and reduce costs in all the industries that you or I might be coming from. In banking, for instance, it is being used for customer relations and for authentication. I don't know how many of you have been to SBI, State Bank of India, their smart bank in Mumbai. But that bank, it is their largest branch and it does not have a single human being because all of the functionalities inside that branch is driven by AI. In retail, almost 10 years back, I implemented a solution where inventory could be managed completely by robots and in an entire warehouse management area. So, and that has only become far, far more sharper. Predictive maintenance. Last year, I was doing a piece of work with a steel company. The steel company had 8 individuals managing the temperature of a blast furnace. However, then they were able to put in sensors that would control the temperature of the blast furnace, optimizing the production of steel, and thereby not only reducing costs, but actually improving the quality of the steel and the predictability of the steel that was coming out. My favorite example actually happens in healthcare. So I was serving a client in Japan, and we are all familiar with smartwatches and how it can, monitor heartbeats and various other health devices. What I saw was quite mind-blowing. Actually, the urinals are fitted. So the urinals you have at home, they are fitted with a sensor. You don't have to wait to fall ill and for a doctor to suggest a urine test for you to take a urine sample in a tube, give it to a lab, for the lab to test it, and for 24 hours later come back and say you've got dengue or whatever. These sensors every day are testing that real time and feeding the data back to your watch. Again, Japan, where the population of the elderly is far greater than the young and the cost of labor is very high, AI is being used for, home care and for personal care of the elderly. And education. Again, I won't go into the details of education because there are many, many examples. Many of you would have been on online courses and how robots are now teaching students and teachers are standing by and looking at that and using it for far more cognitive learning than day-to-day learning. So, and I just took some 6 examples out here. The truth is, you could touch any sector, any country, and there will be an organization using a use case of AI to drive revenue, to reduce costs, or to improve customer experience. So we talked about some technologies, some applications. At the end of the day, conceptually, AI is quite simple. It's taking a whole bunch of data. And what has really changed is that the volume of data available to AI is far greater. It's coming out with a bunch of outputs, movements, robotics, automated processes, decision making. But what is interesting now, if we have kind of established that AI is important, what the next step is what is this black box, this black magic called AI? When you start unraveling that black box, behind that is a process of automation, it's a process of machine learning, and a process of deep learning. And furthermore, if you start simplifying that, then you're talking about algorithms in RPA, algorithms in conditional automation, and in cognitive calculations. These are all advanced forms of bringing together different technologies. The root of the technologies are really only 3. You need to know programming, you need to know some amount of mathematics, statistics, data sciences, and you need to be able to combine data science and algorithms to be able to train a program to self-learn that. I just want Rohan to take a minute to talk about, with this kind of clarity, and when Rohan was speaking to me, okay, how can he start on his journey of learning AI, what he did, because I hope that will articulate to you that actually starting on this journey is indeed quite simple.
Right. So first of all, I'll just go into some of the languages that are used for AI. So Python's normally used for AI, R is normally used for AI, Octave is also, Octave and MATLAB are also sometimes used for AI. The reason for these four programming languages being quite prevalent in prevalent for use in AI is because they are syntactically rather simple. If any of you have ever used Java or C++, out there you have to define the variable as an integer type, as a Boolean type. In Python or or Octave and MATLAB, you don't have to do that ever. It will automatically find what data type is suitable for a given variable. They're also very, very powerful. Python, Octave, MATLAB, all can all calculate matrices by themselves. Like for matrix multiplication, you can define a matrix in any of these languages. I just do and if you have matrix A and a matrix B, you can multiply the matrices to get matrix C equal to A into B. It's one line of code. In many other languages, you'd have to define an entire method or an entire method to do that, and it would be quite time consuming. Finally, Python has packages that let you do almost anything you want, because for example, for computer vision, you want to use your camera to sense something. There will be a package online that will allow you to use your camera to sense an object and simplify your code quite dramatically.
I think the most important thing is that as these languages have evolved, and look, I'm 46 years old. I started my programming languages back in 1986 with something like BASIC, and then did C and Unix and Java and God knows what all languages. But obviously, as computing languages have developed, there is a very, very user-friendly set of libraries and methods that you can call upon. And Python happens to be, one of those examples. I'm not advocating here that that is the only thing you need to learn for AI, but it is an easy thing to start learning in case any of you are interested and you're wondering what you need to do. The other thing, so that was one skill. So if you go back to the previous slide, that's the algorithms part. The other part is then the data and the data science element, where an understanding of some databases and some statistics skills starts becoming important. From a database standpoint, look, I have grown up learning how to use SQL. Very recently, I've been exposed to Tableau and Alteryx, which are like life-changing as far as I'm concerned with the kind of data that we use. If you really want to use a lot of unstructured data, obviously many of you might have heard of Hadoop, which obviously is more than $1 billion valued organization. But regardless of which database you use, the important step is to understand the structure of a database and then learn some basic statistics skills, starting with something as basic as linear regression and going up to support vector machines. Do you want to touch upon linear regression, Ron?
Yeah. Linear regression effectively looks at finding the best fit line among a large number of data points. So if I have a large number of data points, all linear regression will do is try to find the optimal path through those points. Another statistics skill that is used quite often is that of classification. So in classification, an algorithm will look at a large number of data points and will classify them into two or even more separate groups, depending on certain conditions that you tell it to differentiate them based on. Those are two very common statistics skills that are used in AI.
So if you think about the insurance example that we showed, the two cars crashing with each other, effectively there's an algorithm that is getting many data points. It is getting that the car has parked at a curb. It is getting that there was a sound that sounded like a crash. It is getting the fact that some backlight has been damaged. It's getting that the GPS coordinates. There's a whole bunch of data points it is getting. And based on those data points, an algorithm that is self-learning is trying to assess what is the situation of the end user, which in that case is the driver of that car, and therefore what is the response it should get. Quite possibly the response could have been different. In the first stages of AI, the response could, the sound could have been misinterpreted as the car having walked through a showroom. And the response might have been different. And therefore, that's when you actually say the output is not that, it's that of an accident. That's how the machine learning happens. Now, linear regression obviously is the most simplest form, therefore, of taking data points and predicting an outcome. But as you look at, as Rohan was talking about Python and the different methods now to be called upon, similarly in statistics, if you go to the extreme right of page 12, the support vector machines are like methods that are called upon so that each and every time you're not given individual data points and asked to form an outcome, but groups of data points or groups of vectors start becoming self-predictive. So I just wanted to touch upon this, that there are some myths about AI. There's a myth that AI is for the movies. It is just another tool. It is a machine. It's got to be a robot. Actually, what AI is, it's quite simple. It is taking a set of data, creating a bit of logic out of it, doing so in a very, very fast manner, and getting to an answer that makes sense. It is, once a machine has been trained to form an output from these data points, it's very difficult to go back and decipher why the output was what it was. Like if you think of linear regression, 20 data points and one outcome. All those 20 data points give you that equation of y equals mx plus c. But to say how is the outcome, how is the y related to each x becomes very, very difficult. Unfortunately, you can't go and buy AI. It has to be learned. It is built on a lot of data coming together. And as that central learning happens, our interactions with the machine change. It is not about taking away jobs from humans. It is about making humans far more useful in what they were born to do, which is cognitive stuff, rather than decision making that a machine is also able to do. I often get these questions about, will AI come and rule the world and will all jobs be made redundant? It is the same question that happened when steam came through or when the industrial revolution happened. We as a civilization cannot continue to live looking behind us. We have to look ahead of us. I would strongly recommend reading Sapiens, and that explains the journey of humanity and civilization very well. But for us all on this call, we have to believe that A, it is the skill of the future, and B, it is easy to learn. And without this, some of us, and definitely the next generation, will not be able to survive what this world is going to throw at us. I know we had around 30 minutes for this, so I don't want to go into the next few chapters of talking about some details of Python, some details of linear regression. I want to pause here and see if there are any questions either on the chat and or on voice.
Yes. We are just waiting for a question, Rajiv. So my suggestion would be we should be able to at least show one or two screens what we have prepared for a showcase of a Python and the data science, just to give a flavor of them, because anyway we are going to share the deck to them for them to go through and get the outcome of it. So that would be good. Maybe a Python first.
Yeah, so let us do one or two slides each on
Yes.
Python and then on data sciences.
Yes.
So look, at the end of the day, and I do not know, I'm sorry, I do not know the background of many of you who are on this call and how familiar are you from the IT sector or the non-IT sector and the roles you've done. So assuming that you're not that steeped into IT services, at the end of the day, AI is a machine learning algorithm. There's a set of inputs, there's a set of outputs. Now, obviously, that is traditional. Where this changes is that there are a set of parameters, what we call W on the screen, that actually keep changing the output based on the parameters. So if you think about a simple algorithm, which is a straight line equation called y equals mx plus c, every time you give the same x for a constant m and c, y will be constant. However, what would that equation look like if your m and c kept changing and your y had to learn? Now, if you take the simple straight line equation and put it into an equation that is called y equals m1 x1 plus m2 x2 plus m3 x3 up to mn xn, then all those m's are your parameters in a simple straight line equation, and your output is however one, but it keeps learning every time an m changes or an x changes. So that is the basic concept. Do you want to just, and I know Rohan talked a bit about Python earlier, but Rohan, you want to talk about the open source and so on of it a bit?
Right. Yeah. So as it says out here, Python is free to use. It's very easy to download. You just go onto the website and download it. Again, as I spoke earlier, there are multiple libraries that allow you to solve common problems. So I know that there's a library called OpenCV that I actually use to develop the program that I talked about right in the beginning. I also talked about how it's easier to learn than C++ and Java because it's syntactically very easy. You're not spending time writing int x, boolean y. You don't need to learn any of that. That makes it very easy to use. Due to all of this, Python is just a very good place to start for any person who's looking to enter AI, and even any person who's just looking to enter programming in general.
Absolutely. I mean, I'm very impressed actually that schools are now starting to teach Python even at a much earlier age, class 7, class 8, I see school students learning it. And the underlying building blocks of Python is very simple. There are a bunch of data types, integer, float, and so on. A whole bunch of data structures, your conditional statements, which are if situation X happens, then answer is Y, else answer is Z. You need to go through iterations, the for next loops, and then all of these come together in algorithms. So look, don't want to get into a Python training course out here. It's something interesting. I could do another session. But I just want to pause here on Python, and then, as I said, I'll share the slides after this. But the slides talk about the data types, the data structures, the conditional statements, and the algorithms. And we try to make it very, very simple. And then we take one little example of a problem statement about a cab service wanting a drop down of all default drop locations, and literally 4 lines of code how to do that. This is exactly, it's literally this much. These 4 lines that an Uber driver is using today. It is, when I first did programming, the same thing would have taken me probably 800 to 900 lines. But this can now be done in 4 lines. So just wanted to touch upon that. And the other thing we wanted to touch upon is the statistical measures. Now, obviously, all of us have done a bit of statistics and maths in school, and we understand the basic concepts of mean, median, mode, and standard deviations. At the end of the day, statistics basically uses the same concepts, and it has these various models, many of them being regression models, like whether it's linear regression, Rohan talked about it, or whether it's random forest, which is a bit less structured and uses unstructured data like photographs, like qualitative information from Facebook, likes, and so on. But those are the machine learning algorithms. These algorithms can be supervised, they can be unsupervised. There's a whole range of things, and I would actually urge any of you to do a simple course on that to see how this works. We'll send you the slides on a fitted regression model, and again, the pre-built libraries that exist to do any of these models, whether it's linear regression or random forest. So I'll finish with one last slide. I think there are a whole bunch of courses, a whole bunch of material available online. Rohan talked about Python being free and downloadable. You should be able to go on any of these, plus Coursera, and pick up any of these skills. As Manjula said at the beginning, I'm working with initiative at NASSCOM called Future Skills, and we are looking to synthesize all of these, with Edcast as our platform partner, to make it very, very curated as well. Obviously, there's potentially a certain cost, etc., associated with that. But again, I'm getting NASSCOM and Manjula and her organization to see if what's in the art of the possible there. But there isn't a dearth of good courses available should you choose to dabble into this, and then based on the fact whether you're excited or not, actually start becoming more of an expert at it. So I'll pause here, and I know some of you have posted some questions online. Let me just see if I can get there as I stop sharing, and I'll start going into the questions.
Yeah, I can also just walk through just to pick it up, Rajiv. So
Sure.
how about Scala? Is it something compared to Python? Would you like to just answer that?
Yes, so I have used Scala very recently in a media company where we were doing a AI project. Actually, it was about predicting user behavior. Scala is very powerful. I would, if I have to give a very simple answer, and look, it's a less nuanced answer. It is not as intuitive as Python, although it has some capabilities that are more powerful than Python. So if you are not a beginner, if you're more an intermediate or advanced person, then Scala would be good. If you're a beginner, I would not strongly recommend it.
Sure. So there's a question from Hemlata. I have fair idea of ML algorithms with Python. Is the data science application are straightforwardly using these algorithms?
Good question, Himlata. So actually, we rushed through it a bit. When I send you the slides, look at the section on chapter 3. Earlier, if you had to do linear regression, and that's a simple example, but let's take random forest, which is not such a simple example, used a lot by Facebook for predicting, what you like and for the ad optimization. Some of the random forest applications, which till a few years back needed many lines of code, now are easy to call libraries that you can use, whether it's Python, Scala, or any of those languages. So the simple answer to your question, yes, most of your conventional data science applications are simply call-ins, if you know what library to call in. As you do more predictive analytics and you come up with your own algorithms, then those are not libraries, but some of the most standard ones are very simple call-ins.
Perfect, thank you. And there is a question from Sugita. Control systems can become more efficient using AI. Yes, that's true. But go ahead if you have anything to add.
Yeah, so that was the genesis of AI. AI's birth was industrial control systems, actually. It was not Google and Siri and Alexa and so on. The entire thing, even 20 years back, was how do you make a machine running, and as parameters start going outside a certain high or low band, make the machine self-learn and bring it back internally. Whether this was in industrial or electrical, this was the genesis of AI. Control systems are probably one of the most advanced use cases of AI today. Nobody even uses the phrase AI, they just assume control systems is what that is meant to be.
Okay, so there's one more question about Juvaria. Wanted to know about scope of QA in AI.
Sorry, could you repeat the question, Manjula?
Scope of QA in AI.
Scope of QA, quality assurance.
Yes, that's right, quality assurance.
And in which industry are we talking about? Is it in the IT industry? Is it in manufacturing?
Predominantly in the IT, I guess. So that's where it is a question.
Yeah, so look, again, the other area that has made significant advances. So, okay, let me take a step back. The testing part of IT was one of the earliest IT functions to be quote unquote commoditized. The commoditization of testing happened as a result of testing tools, and then the testing tools became self-learning to identify what scenarios to create to test your programs. QA, a large element of QA is checking if the right scenarios have been tested or not. And so to that extent, QA has a fairly large use case from an AI perspective. Having said that, the IT industry, 65% of which from a manpower standpoint resides in India, has not invested as much as they could have in AI, predominantly because of the commercial models, where the business model, the commercial models have been largely per FTE basis. And as a result, there's the IT industry, which has been provocative about pushing AI in other industries, has not been the first of the blocks to embrace it, because it leads to reduction FTEs, and therefore reduction in revenues. That is precisely the program that we have been working with NASSCOM on future skills to realize that if the IT industry does not embrace this soon enough, then other countries will start taking over the competitive advantage that India has had. So short answer to your question, QA and testing, deep use case for AI, Indian IT organizations have not been at the forefront of using it. If they don't, they will lose out in competition to many other countries that are starting to compete in the space very rapidly.
Fine.
I don't know if that answers the question, Manjula.
Yeah, thank you. So there is one more question from Hemlata again. Does these AI application make use of available ML algorithms, or developers should develop from the scratch? I think you answered it already, but just go ahead, just summarize that.
You should never have to, unless you're doing something very, very specific, you should never really have to develop your own ML algorithm. You should almost always be able to find one that's already in a library, and you should be able to adapt that to your use case. Obviously, it's a good idea to know how it works, but you don't really need to go too much into developing it from scratch. You should be using libraries as much as possible.
Great. Thanks.
Principles is not that much needed. There are advanced use cases where you will not find an algorithm in a use case library. But if you look at various players, whether it's RPA players or ML players, they are constantly updating their libraries with, generalizing various use cases. So chances that you'll find an algorithm is much higher.
Right. So just to take a pause on that, reflect on what we are talking about. So Rajiv was just talking about there are a couple of courses available, etc. So the first thing, the essence of it, Rajiv, the way we understood is for AI, we would like to know the little bit of a programming, which is your recent languages, like in kind of a Python is the base for that. And along with that, some data science concept also, which is your R or whatever the system, if we just know a little bit of it, mix and match by training them or whatever, which is a simple use case part of it. So, and the resources, what you have shared is the simple steps, as well as the deck, what we are going to share it to them is also the one more primary level for them to go through that. How do we make this AI for all, being as a little bit of a IT knowledge, how do we make use of it in started applying all those things? Is that in a nutshell are we talking about?
Absolutely, Manjula, you couldn't have summarized it better. As I started by saying just two simple messages. AI is here to stay. We will all be better off if we embraced it and did not resist it. And AI is relatively easy to learn. It's not black magic. Depending on your starting point, just get on with it if this is a topic that interests you. I do not want any of you to leave this session thinking that we are advocating Python or Hadoop as a database or something. There's a multitude of programming languages, there's a multitude of databases, there's a multitude of statistical techniques. You will find different ways to use them. Just get started, depending on whatever industry you come from. I see some questions about telecom industry, about electrical engineering. There isn't any sector or any industry where this is not of use. So just get started on it, and you'll find a use case in your industry. Apply a bit of that learning to your context, and you will see that actually very, very quickly, I mean, I would not even give it more than 2 or 3 months. You will start loving the topic and you'll start seeing the practical use of this.
Just to add to that, Rajiv, in fact, I wanted to just share this. Learning is not that difficult. And we have also partnered with UiPath for RPA automations, where official partners, as well as we do just reskill the professionals for the Python. And that's a L1 training. We call it as a L1 training precisely. One for developers and one for automation part of it. The L2 goes to the next level where they just integrate with the data sets and then find how to bring the AI part of it. So it is literally the moment, because as you rightly said, the future skill is that. So knowing the C, C++, Java is no longer is going to be useful unless we just get adapted to the what industry wants that. So
Exactly.
the reskilling, like NASCOM, we are just working with NASCOM as well as with other companies and everything. This is just becoming the need of an art. And as you rightly put it across, easy to start from plain slate, even though we don't have any knowledge. That's the beauty of it, what we are talking about. So is there a last question where we can just pick it up before we just wind up?
Absolutely.
So there is a couple of questions, as you rightly said, electrical and other industries. So there is a one person from Sudha. I am from pharmacy background with few years of experience in healthcare sector and would like to change my domain. I would like to get into AI. Could you please guide me on this? Feel free to pick it up. Otherwise, I can pick it up, Rajiv. Anything is fine. Go ahead.
No, absolutely. So look, AI's use in healthcare is actually quite advanced. Unfortunately, India, to be very honest, is lagging behind. Our use of technology in healthcare for various economic reasons has not been as great as global, but globally, healthcare is a absolute right spot for AI. So Sudha, what I would suggest is you could position yourself well with your domain knowledge and the technology knowledge to start making a change out here. I would urge you to start looking at AI use cases in your domain. You said you're from a pharmacy background, so that's more B2C, and look at business to consumer examples. I'm happy to, when Manjula shares out the slides, I'm happy to share my email address or my contact details. Look, today wasn't an aim to, get all of you to become AI professionals, but I'm very much available if you have any questions or something, reach out to me and very much happy to guide any of you one-on-one with whatever little knowledge that I might have.
Right. So, along with that, if you have to change the domain to AA, again, as Rajiv was mentioning about the concept, the pillar is the two pillars to start with. One could be your little programming aspects where you need to be knowing about it. The reason why Python has been picked up, as Rohan and Rajiv was talking about, you can say A equal to 5 rather than to decide about it's an integer or your variable, all those things. The natural way of talking is becoming a way of programming. So that becomes easy for you in a month's time to get comfortable with what is the programming all about. And then once you're familiar with that, the next set of that you're going to handle is your data part of it. Again, the intro session. The moment you have the little basic, then with your domain experience, what you're talking about, which Rajiv is talking about, the B2C use cases, etc., you would be able to correlate, articulate, and then talk about in a better, broader perspective and try to get into the deeper sense of it. That is where your next level of learning comes into the picture. For the level 1 learning, either your online resources is good enough to just get the basic understanding part of it, or the programs like what we just run, our L1 programs or something like that. If you are interested, happy to assist you as well. And Rajiv is also just pushed his hands together to just say that this is my contact details available. So we are all available to make sure people are not getting averse with AI, and it is literally easy to kickstart with the help of internet and with the help of communities like that. It is easy to do that. So thanks, Rajiv. Right. Okay. So thank you so much, Sudha. Thanks for asking about it. Feel free to just connect with us. For everybody, thank you so much for being with us. And indeed, it is a pleasure to have Rajiv and Rohan with us. And thanks for taking your time and being with us. So if based on the feedback, we will share the feedback to the audience. And based on the feedback, if we need a practical session, we'll go back and then plan for one more as well. So thanks for joining and have a good day. Thank you so much.
Thank you, everyone. Thanks for your time.
Thank you.
Thank you. Bye-bye.
Ask a 5 minute recording.